Hi, I am Dr. Isara Anantawarasin. Welcome to the second session of Object-Oriented Analysis and Design. In this session, we will focus on models and modeling. And no, not the one with cameras and nice clothes. We are talking about software modeling. A model, in general, it is an abstraction of a system. Right? A system that is no longer exists, a system that still is, the future system that we might want to build. If a model is an abstraction, what is an abstraction? In the field of computer science and software engineering, an abstraction refers to the process of simplifying phenomena or events or things by focusing on the essential characteristic while hiding unnecessary details. It involves creating a higher level concept or representation that captures only the key aspects or functionalities of a system or a lower concept or even a concrete object. Abstraction allows us to ignore unnecessary details or complexities. And these higher concepts or abstracts can be expressed or described by models. All right, so let's come back to model. A model is a representation of a software system or maybe specific part of a system. The software models are created to facilitate the understanding, communication, and analysis of a software during the development process. It helps us to visualize, to document, and to organize a lot of many elements or relationships and behaviors between components in our software system. The software models can take various forms, right? It could be a lot of things. For example, diagrams, textual descriptions, mathematical notations or equations, or prototypes. All right, it could be paper-based prototype, it could be UI, or it could be some even sophisticated prototype like working software. Different models can be used to address different aspects of of software development, such as requirement analysis, system architecture, data flow, user interfaces, and behavior modeling. These models focus only on the information that are interesting or valuable to us. Okay, we carefully choose what to discard. Okay, sometimes a lot of them, and what to keep during our model construction. Now let's see some example. This is me. Okay, I'm an ordinary human being like you guys, but we could be different, right? I got black hairs, I got black eyes. Okay, I'm wearing red shirt right here with this red cap. Okay, and of course I could wear differently. We could be of different heights and so on. Now my description, okay, however you describe me, okay, even names, you cannot use this description to describe all human beings. If you want to describe human beings as a whole, we're gonna have to take away a lot of details, right? My eye color, my hair color, okay, my height, my weight, my name, even, all right? Well, you take away this thing and keep only important stuff, only important features or characteristics of human beings. Like we have two arms, we have two legs, we walk straight, okay, and we got hairs and nose and so on. But this description of human, of course, cannot describe this guy. Okay, he doesn't walk straight. He doesn't just have hair on the head like us. He got hair all over his body. All right, some part white, some part is black. Okay, some black eyes and black ears too. Well, somehow nature make him cute. I'd say cuter than us, but still, all right. This is description of panda. You cannot use this description to explain any other mammal as well, like maybe a dolphin, all right, a dog. Can't do that, all right. So if you want to describe mammal as a whole, we need to take away some details. All in all, maybe we're gonna end up explaining like all mammals are the animals that just feed babies with milk. And I think that's pretty much accurate. All right, that covers everything we want to cover. Yet that description of mammal cannot describe all animal. All right, like jellyfish, they don't feed babies with milk, as far as we know. All right, and if we want to describe animal as a whole, we even need to even further abs- um, discard more detail. And this level of detail, when you want to go from concrete object like me, okay, to a higher concept like human, to a higher concept like mammal, to a higher concept like animal, and maybe life in general, okay, you need to abstract away, you need to remove some detail. This is a process of abstraction. One of the most important quality of a good software engineer is to be able to identify what to keep and what to throw away. All right. You need to find similarities between things. You can't just keep all the details. You can't just take care of all details. And the customer and the users could overwhelm you with a lot of data, a lot of documents, and you can be like, "Oh man, this is overwhelming. This is gonna be, it could be a lot of stuff, and we need to keep, um, get some data structure schema to keep all this data and how to compare those data." But according to my experience, these complexities, okay, of a system could be taken away, could be lightened if you know what to keep, if you know what to discard. All right, so let's further model our human being, okay, using some software engineering language or software model. This is me. I'm a human, okay? Well, I am an object of a human. Human is a class because it explains everybody, okay, in the world. And then human is a subclass of mammal, okay. And here mammal is again a subclass of animal. I'm sure that you are familiar with this notation or at least have seen that somewhere, okay. Here I say that right here is my name, okay, colon something, this is a class name. It means that I am object of this class or instance of this class. And this one, this arrow with some large arrowhead like this, okay, indicates that human is a subclass of mammal. And this, again, this arrow indicates that mammal is a subclass of animal. So you can think of it this way. I am a kind of animal. No, I am a human. Sorry, I am a human. Human is a kind of mammal, and mammal is a kind of animal. And this property is transitive. So it's basically what it means that I am a mammal and I am a animal. Okay. So let's have a look at the notation. Well, we use this part is what we call UML diagram. Okay. This instance of or subclass of and so on. This is class diagram. Very minimal, yet it is a class diagram. Okay. But when we translate this model, okay, in UML into actual implementation, it could look like this. okay, class human, okay, which is a mammal, and then what is what is the feature of this class? It has to walk upright, true, okay, and we can also do some reasoning. Mammal, on the other hand, okay, is a class mammal, which is kind of animal. We have milk, okay. It's kind of bad language if you ask me, but yeah, okay. Do we milk our children? Yes, true, okay, and yes, the action or the operation of us is to feed our baby with milk, and then you describe animal. Animal has to eat, okay. I mean, it could be a little bit more because plants, I guess, eat too. All right. So, but you get the idea. Now, all properties of animal, okay, got transferred into mammal as well. It means that all mammal can eat, and all human can milk the child and can eat, but we can do more. We walk upright, and we can do some reasoning as well. Before we talk further about modeling, okay, let's discuss these two words first: application domain and the solution domain. They refer to different aspects of a software system. Okay, so let's discuss them separately. First, the application domain. Application domain refers to specific area or field in which a software system is intended to be used or applied. Basically, it explains your user's problems, okay, user domain. Okay, it represents the subject matter or the problem space that the software system addresses. It uh, encompasses the knowledge, concept, processes, and requirements related to specific industry, business, or domain in which the software will be utilized. So let me give you some example. If we talked about air traffic control, okay, the system that control the airports, we need to understand how the air traffic works. Okay, we need to understand maybe the layout of the airports. Maybe we need to understand a little bit more about air in industry, what kind of licenses that the airplane have, or the engines. Okay, the size of the airplanes, how many personnel, what kind of personnel that work on the airport. Maybe how the luggages are being transferred through the airport. All right, so that we can design the system properly. We need to understand the problem. We need to understand where the solution will be uh, employed in. And next, the solution domain. Okay, solution domain represents the technical aspects or technical components of a software system. It focuses on the design, the implementation, and the choices of technologies that are used to build the software. All right. It explains the solution. It also involves making decisions and applying uh, technical knowledge into the solution. For example, I mean, if we are going to develop a system for air traffic control, okay, we need to understand how much traffic there is, how many people are using the system, what kind of passengers do we have, and then we are going to be able to design the system properly in terms of software and hardware. Okay, network infrastructure, hardware infrastructure, what kind of server do we need, what kind of operating system do we need, what kind of securities do we need, and so on. Understanding the solution domain is very important for software developers because it enables the developers to make informed decisions about the technology choices, system architecture, implementation of projects, and so on. But in order to do that effectively, you also need to understand your problems. You need to understand your application domain as well. Therefore, when we create a software model, we need to find abstractions in both the application domain and the solution domain. Now, let us elaborate on our airport or air traffic control scenario a little bit more. Okay. here. In an airport, we have airplanes or aircraft. All right. Forget about this for a while, right? Now, if you want to model all these aircraft, you can put them into an aircraft class. Of course, inside the aircraft class, you can have some attributes or operations that explain an aircraft, right? But this aircraft class is intended to explain all kind of aircraft that is going to use the airport. Okay. Now here, the phenomena are the aircraft. The concept is the model is your class. Okay, that explain all this phenomena. Now, not just the aircraft, of course, in an airport, you also have air traffic control. Here, you can model them as a traffic controller, right? And of course, the airport has terminals too. Okay, you mean the buildings and everything. Okay, here you just model them as airport, and of course, the airport can have some other subcomponents like terminals or gates and so on. All right, but let's just for the sake of our conversation, let's just call them airport. Now, in order to fly in an airplane, you need to specify where you're coming from, where you're going to, when are you leaving, and so on. You need to specify the flight plan. Okay, otherwise the plane can't take off. All right, so hold your thought right there. All right, moving on to the right hand side, we call this. Oh, by the way, I'm sorry. We call this the application domain because this is the part where you're trying to understand your problem. What kind of components do we have? What kind of persons or users do we have? All right, you are trying to explain the environment right here, the actual environment, the actual, I mean, in the real world, all right, of your problem, the real world side of the problem. Now on the right hand side, let's discuss this solution domain. All right. So in solution domain, what can we have? We could have a computer, okay, which we know that it could store data. So we model them as the flight plan database, okay. And we could have the map view of the navigation or flight plan. All right. We have map display. And of course, flight plan can also be displayed as text. We have the textual display, all right? And then, okay, together, the traffic control here, aircraft, airport, and flight plan and everything, you can model together, you can pack them together as the traffic control package here. See, this could be one subsystem or subcomponent. This could be one component. This could be one component or subsystem. This could be another subsystem. And in this subsystem, it contains all these classes when you actually implementing it. Okay. And this diagram right here, the one with the box with a little, a smaller box and the name here, we call them package diagram. Okay, in UML, we call it package diagram. That's why I write UML package here. Okay, UML package usually store classes. So the thing inside here are classes, and each class, of course, explain each of the events or object here, right here. To summarize, on this side, we have classes that explain the problem. Okay, the real world problem, right here. Okay, so we are on the application domain, right? And I mean on this side, application domain. Okay, and application domain, you have the actual events, actual thing, the actual phenomena here. And when you translate this phenomena and maybe you take some detail out, okay, you have concepts, the concept that represent each of these phenomena. And this belongs to the application domain. Now on the right hand side, you have the solution domain. Okay, solution domain, you have phenomena too. You have the actual computer, you have the actual display, okay? And then you have concept here, which is the map display, flight plan database, textual display, and so on. Okay, but please do not let this arrow fool you. Okay, don't let don't let it misguide you, because sometimes when you have not finished or you haven't built this display or program or this system just yet, maybe you have just this. Maybe you start from concept, and then after you have, after you are ready, okay, you are implementing this concept to create an actual working software. Okay, but you are using this to explain this, but in practice, this phenomena could occur after you finish your model, because you are using the model to build this. And here, this is the design phase. You are building your system, you are designing a system. This is analysis phase. You are trying to analyze, the phenomena and try to compress them, try to abstract them, try to create a model. Okay. So now we have analysis and design, but what is object-oriented analysis and design? Object-oriented analysis and design is basically a paradigm where you analyze and design using objects. Okay. For example, here we have a phenomena, which is an aircraft right here, or an airplane. All right. We would like to model it using a class diagram. So you want to model this as a class, and this class could have the name plane. Okay. And we have attribute tail number. This is your concept. A plane have a tail number. Okay. A tail number is the number that is dedicated to this plane only. The first character indicates the country where this plane come from, and the rest is just the the license, the identifier of this plane. Now you have a plane and a tail number. Okay. The next step is when you want to code according to this class, you can implement it in this example using Java. Okay, but it has to correspond to the class. For example, here we have the class name plane. Okay, and this plane has a tail number. Okay, right here in Java we say a private string which says that, okay, this tail number is a string. Okay, and it's a private attribute, so nobody else can see this tail number unless this plane allowed to do. Okay, and it could do more. It could just get flight history, it could fly, it could go to destination, serve food, whatever. All right, now this is Java. What about we do that in Python? Same, we have the class name plane. Okay, and the tail number is none right here because you haven't assigned one yet. Okay, and it could do the same thing, get flight history, it could fly, and so on. All right, so the choice of implementation are totally independent from the model that you have right here. Okay, you see, using the same class diagram, you can use either Python or Java. All right, let's do some modeling together. Here we are going to design a game. We call it the dice game. It is quite simple. Okay, the player can roll 2 dice. If total is 7, he wins. Otherwise, he loses. We are going to model the game in 4 super easy steps. Okay, and this is oversimplified. It's gonna be more detailed in the actual project, but just to get you some idea, all right, we're going to define use cases, we're going to define the domain model, we are going to define the interaction diagrams, and then design class diagram. First, let's define use cases. If you Google use case or use case diagrams, all right, you might see something like this. Okay, you have the ovals, balloon like this, and you have this stick man, pointing something like this to these balloons, right? And every picture that you see here, well, pretty much the same, or the structures are the same. Let me explain to you here. Normally, we call this use case diagram, all right? And in any textbook, when they explain use cases, they usually have this diagram, all right? Similar like this, because this is the UML use case diagram. So we have the bubble, okay, that has a use case name on it, and we have this stickman represent an actor, usually a user, or could be external system that relates to this uh, use case. However, use cases are textual description or story that is used to discover and record requirements. This is the simplified definition, all right? Precise one comes later in during the course. But the idea is use case explains what the user wants, what are the requirements. They are not diagrams. We use diagram to give kind of big overview of all use cases. All right. Generic idea, okay, this system does 1, 2, 3, 4, 5 things. All right. But this is just to get you some quick picture. The explanation, okay, about those 1, 2, 3, 4, 5 things in detail, that's the use case. All right. Good use case describe who the actor is, what he does, and what is his goal. More on that later. So let's have a look at our dice game. All right. This is the use case. Player requests to roll the dice. System presents results. If the dice face values total 7, the player wins. Otherwise, the player loses. Now check this. There are interaction between the user and the system, and there can be two outcomes. All right. So the player requests to roll the dice, and then the system rolls, right, and presents the result to the user. After some calculation, okay, we're gonna see whether the result is 7 or not. Okay, if so, the player wins. This is the rule, right? This is outcome number 1. Otherwise, the player loses. This is outcome number 2. Usually, we derive our use cases after we interview with the users and the customers. All right, we go and interview. We go ask them, okay, what do they do? How do they do it? Why do they do it? Okay, and then we summarize and write them down into use cases. Use case normally explains one workflow, okay, or one goal, one user journey. Okay, for example, in our dice game, explain how the user plays the game. But in the more advanced version, okay, we can also have another use case where the user check the game results or history or high scores, online world ranking, for instance. All right, and these are going to be extra use cases apart from just to roll the dice. After you have the use case, okay, we normally start to define the domain model. In this step, okay, we are trying to describe things in the real world or the domain of interest in what we call the conceptual perspective. Here we are trying to identify the concepts, okay, or the abstractions of the thing that we are interested in, okay, along with the attributes, associations, and also their operations. What do they do? The result of the analysis gonna be expressed in what we call the domain model that shows only important or noteworthy concepts. Basically, what it means is These are the information that we would like to keep. The other things we might not need to. After a long consideration, you end up having these three components in the dice game. Okay. Here, in this domain model that explains our dice game, we have the player, we have the game itself, and we have the die, right? Dice is actually plural, so one die, two dice. Anyway, okay, in the game, the one player plays one game, okay, and one game has two dice, okay. The player also rolls two dice here. Inside the player, the attribute of player has a name, right? Well, and then the one die has face value 1, 2, 3, 4, 5, 6. As you can see here, we are not explaining anything about the software just yet. We don't care whether the name is string, okay, or character, face value is float, double, or integer. We don't care about that yet. Domain model visualize the mental model of the real world problem. It is not a software description. A mental model is the cognitive model or representation that individuals use to understand and interpret and make sense of the world around them. It is the model that describe what you understand from the world around you. This is what you're trying to understand and explain what's going on in the application domain. This is sometimes called the conceptual object model. Just explain the concept, what's going on here, how many people are using this software, how many components we have, how many elements we have, how are they connected or related to each other. In this diagram, okay, called this class diagram, it explains just components and their relationships. See, one of these has two of that, and one of these has two of those, all right, or rows, two of those. It doesn't really explain how are they reacting to each other, okay? It doesn't explain how the players actually roll dice, okay? What are the information that are being exchanged between the two objects? It doesn't explain that. It explains just components or structure of your software or of your domain. To explain interactions, we use interaction diagram. Okay, UML provides a few kinds of interaction diagram for you, but right here we are going to focus on the sequence diagram. Okay, sequence diagram capture the messages that are sent between objects. Okay, object 1 tells object 2 to do that, object 2 returns a result. Right? And normally when we use sequence diagram, you need to understand this. We are not using sequence diagram or pretty much any kind of diagram in UML to explain the actions. Okay. When I say player rolls dice, for example, okay. When I say the user or the player rolls dice, it means that the user send the message roll to the object die. Okay, then the object does the rolling, and then returns the result of rolling to the player. The player doesn't roll, not like in real world where the die doesn't move or the dice they do not move, right? You just have to pick them up and you throw it. But this is a computer software, so you are going to tell dice, please roll yourselves, and the dice, both of them roll. Okay, my face is 2, my face is 5, and the game decide, okay, 2 and 5, then the player wins. Let's have a look at it in detail. Here we have a dice game object, okay, and we have the die object D1 and the die object D2. Okay, so let me explain a little bit more about sequence diagram if you're not familiar with. Um, Here we have this box on the top here. This box represents an object. Okay, it sounds like a class because this dice game is a class, die is a class, die is a class. But is it actually an object? You see a colon here. Okay, if it says D1 colon die, it means that this D1 is an object of a class die. D2 is object of a class die. All right, but this one we have colon without nothing in the front. Okay, it means that we don't care about the name. Any object of type dice game would do. But here we want to distinguish between two dice, here. So it'll be D1 and D2. Therefore, we require a name to distinguish between them. But for dice game, they're just any dice game would work. All right, it doesn't matter. It doesn't matter in this conversation or this diagram. Now, message play could be sent from the object player. Okay, play the game, and this message play is sent to dice game. It basically says, dice game, please start your game, right? But once the message play comes, the dice game start. This is the, well, we have a session for this, but just understand that, okay, this is the starting point of the play method, okay? Now, during this playing, the roll message is being sent to the D1 die, okay? And then the die roll itself. Then the dice game requests the face value that is the result of the rolling. And then the D1, okay, return FY, which is face value, back to the dice game. And then once the dice game get the face value of the first die, he sends the same roll message to the D2 die, okay, and then get the face value and get the D2 die. It sends the face value back to the dice game. It is quite simple, okay, but let me tell you again. I want to emphasize again, and this is very important concept. Anything we do here, okay, roll, get face value, roll, get face value. You are telling this object to do the work. You are not doing for it. Okay, you don't touch the, at this point, you are not touching the die at all. You just say roll, and this guy roll. So what's the result? Return the result. Now let us move on to the software side. Okay, here we have the design class diagram. The design class diagram is used to describe model of a software system in the design perspective, okay, or software perspective, in contrast to the conceptual perspective. This here, you are trying to derive a class diagram or any other diagrams that try to explain the solution, how the dice game should be constructed. Okay, this might include the attributes, methods, or the operation of each class. It is, of course, more elaborated model that describes the software specification and interfaces. It could explain that, okay, I want this as text, I want this as numbers, could be integers, could be floating point. Still, it is platform independent. What it means is that you can use this design class diagram as a generic model, okay, that could be used to implement in any kind of languages or libraries or platform, Windows or Mac. It could be a Python, it could be Java, okay, it could be Golang. After this step, we can finally implement the game. Now, let's see how things are fit together, okay. First, we have a conceptual perspective model, okay, or domain model. It's quite simple. Just say, okay, one dice game has two dice. All right, and each die has a face value. Quite simple. Okay, doesn't explain much. Now, when we move on to the design class diagram, we are moving on to the specification perspective. As the name suggests, we're moving on conceptual perspective to specification. Okay, we would like to be more specific. Now, in a dice game, you have two die 1 and die 2. Okay, and the die 1 and die 2 is of class die, and it can play game. Okay, and in each die, the face value must be integer. It doesn't make sense to do double or float. Okay, and it could do two things. It could roll, and it could return the face value. Okay, and the result of this function to get face value is integer. Okay, so whoever send me this message, I will return him integer. Okay, but you can go a little bit deeper and more specific if you are going to implement. All right, let me go back one step. Right here, okay, if you are being agile, if you're being quick, you can use this level of diagram to code already, because the programmer can decide, okay, this is integer and this is die. Okay, die is another it's a class here. I think we can use this data structure to store this. We can use this algorithm to compute the face value. It is just the detail is left to the developers to decide. Okay, that's fine. All right, but if you want to be more specific, for example, if this component is very complex, okay, or if you want to be sure that we have 50 people and they are on the same page, you want to be you want to maintain tight detail. All right, and if you work waterfall, okay, sometimes the customer also wants to know this as well. They want to understand, okay, what is going on in the development, what is going on in the software, right? You can go to the implementation perspective. In the implementation perspective, you specify even more than that. Okay, get dice value. Okay, you're gonna return the dice var, which is an array. Okay, and you have this integer and this returned integer and so on. And this is a subclass. Die is a subclass of Java lang object. This indicates that we are now depending on the platform, because as you can see in this example, okay, Java lang object is the most is the superclass of all classes in Java language. All right, and if you see something like this, you kind of immediately see that, hey, we are now stuck with the language, because sometimes when you use Python, you have some specific data types, you have some specific class or libraries that is provided by Python. If you are using other languages, okay, C# or C, C is bad, but C# or C++, okay, you have some specific data types. There's a structure or other libraries that are provided by those languages, and now you are depending on those types or those classes. That means that you are moving further, okay, more detailed, more concrete, from just the concept to concrete. Okay, here we talk about domain model. We explain how things work in the real world, and now we are in the system model. We try to explain our solution, our system. You can do two steps, just a simplified version, platform independent, or you can be more specific and super concrete by the digging down into the specific platform. It could get scary as well, right? We have just two classes. Do we need to produce three versions? Well, in practice, not really, no. Okay. Well, in some projects, yes, but normally you don't do that. See, you can just start from here and you can add information along the way. Once you're moving on to detail and more detail and more detail, you can add attributes, you can add operations or methods um, along the way, all right, to this model. So it gets more detailed, and you can even get more detailed here. So in the end, you might just have two classes, just have like different versions, because you keep working on your implementation. You come back and and update your model, all right, and back and forth you update your model. And once you have some other requirements, when you add new features, you're gonna come back to you might need to come back to update your existing class also. Okay, a pro tip for you guys. The main purpose of modeling is to understand the problem and to understand the solution, not to document them. All right. You don't want to elaborate too much. The SA job is to capture the problem domain elements and quickly explore possible solutions. And I would like to emphasize here, hold on, let me get to the pointer, possible solutions. All right. There could be more than one solutions. Okay, the more than one angle to attack the same problem. All right, how to implement the rolling functionalities. Okay, how to keep track of the flight path, how to display the flight path, how to display the phase values, how to compute the phase value. All right, there could be many ways, and once you understand the problem, you should move on to, okay, how should we solve the problem? Okay, what is the best solution we have? And not to document all implementation perspective classes. So basically, you don't want to keep in detail, like I have like 20 classes. I need to write them down. These classes have these attributes. These classes have this method. I need to write them down. No, you don't have to do that. Okay, well, in the past, and in sometimes when you work with the government organizations, they want you to write down every single detail. They want to make sure that everything is correct. Okay, and they want to check. I mean, even the customer wants to check. Okay, this is what we understand, right? And then they want to make sure that, okay, the programmer, the SA, and the customer or the user are on the same page. However, programmers have brains too. You don't need to write down everything. I mean, in SA perspective, you don't need to write down everything to explain to the programmers. Okay, this is what I study from the application domain, and this is what you need to do. Please implement precisely like this. You don't have to do that. Okay, it takes too much time. And here's the thing: even though you invest 2 or 3 months to draw these diagrams, in the end, once you implement, changes occur. The thing that you plan to do, the thing that you specify to do, might not work, and when you realize later, you need to come back and change your models, right? This model got changed all the time, and we are gonna see when we see each other in the lab, right? When you add some element into your UI, the classes changes. Okay, when you design your sequence diagram, okay, how the class are interacted, you can be like, oh, okay, I think I need this operation also, and then the class diagram got changes. Okay, so change occur all the time. You need to keep things simple, right? The simplest thing is white. I'm telling you this. All software companies have whiteboards. Sometimes there are walls full of whiteboards. Okay, so we use whiteboard to draw simple diagrams. We don't have to elaborate the diagram even, and you use whiteboard for everybody to see at the same time. So what it means is that there are many times that the programmer, the SA, the entire team need to use the whiteboard to discuss, okay, to change, and then to explain and to exchange some ideas. Use good enough notation that all parties understood should be enough. Okay, so basically, you don't need to be in detail as long as the detail is just enough that everybody understand what the system do, everybody understand what they have to do to invent the system. That should be fine. Do not overcomplicate things. Okay, guys, that's it for this session. We have seen the overview of the entire software design process. Next week, okay, we are going to discuss the requirements elicitation. We're going to see in detail how can we collect requirements from user, okay, and how can we create the software vision documentation, all right? And we're going to get to detail of each of the developments of the design step later. But right now, thanks a lot for joining me today, and click subscribe and like the video, okay, so that when the new video drops, you're gonna get the alert as soon as possible. Otherwise, follow us on the Discord channel as well. Bye.